So today is Wednesday, day 8, and we will go over some short things today. And first, we'll go into Millman's theorem, which is basically what kind of a shortcut can you use in designing a voltage distribution system or voltage system that uses parallel voltage and resistive networks. Okay, so if you have basically if you've got a bunch of a battery with a resistor, all these parallel situations, different battery and different resistors um, in series with one another, and then all the different branches are tied together at two ends. Then you'd like to know what the voltage is from one end to the other. And Millman's theorem essentially gives you a way to calculate what that voltage output is. So in cases where you have an oddball voltage, maybe, you can't rebuild it up with 6 volts or 12 volts. You need, a number of 3 volts and 6 volts put along with some certain resistors, putting them all together to get some oddball type of a voltage output. We use Millman's theorem to create such circuitry. Okay. And then on the larger end, we also need to, if we want to distribute voltages to a plant or some mechanism where it requires a lot of power, we like to use three-phase current, which we'll get to when we get to AC circuits. But basically, these will be a set of resistor networks that are shaped in a Y configuration or a delta configuration. And again, there are ways to convert from one to another and also abbreviate or condense the system to make it easier to work better for you. And so we will go over that, the Y configuration and the delta configuration. And then when you get to motors and generators, we will discuss them even more in upcoming classes. So we will get started now with Millman's theorem first, and then Y and delta circuits.